Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is the final video in a series on the hyperbolic functions for a Calc 1 course. It is also the final video in a series on differentiation rules for differential calculus. So this rounds out kind of what's known as the core information for derivatives in a Calc 1 class. As I say in this here, by the way, you should have watched all my videos up this point on hyperbolic functions. Now, as I say here, to be honest, the power of knowing the inverse hyperbolic functions comes from knowing their derivatives. While these are not necessarily memorizable, it is very convenient in Calc 2 to remember the first column. The second column, not so much. But the first column, it's not that you're required to memorize these. Not at all. However, it is a little bit powerful if you can remember them. Not a lot of students can, and that's okay. But you'll run into, in Calc 2, a lot of situations where you're dealing with these functions right here. If you happen to know that that is the derivative of the sinh inverse, then you can speed up your computations immensely. Not a lot of people are going to remember that, so okay, that's fine. But just letting you know, these are kind of interesting if you can remember them. Now we're just going to pick one of these to prove, and I'm just going to prove the cosh inverse. They all kind of rely upon the formulas for the inverse hyperbolic function. So just as a reminder, cosh inverse of x is equal to the natural log of x plus the square root of x squared minus 1. Now, you could go ahead and do this the way you would prove an inverse trigonometric function, except that you would have problems finding what quadrants, quote unquote, that the inverse returns into. So I think it's much easier to go about the proof this way. So the derivative with respect to x of the cosh inverse of x is going to be the derivative with respect to x of the natural log of x plus the square root of x squared minus 1. Well, the derivative of a natural log is 1 over its argument. 1 over its argument, x plus the square root of x squared minus 1, times, via the chain rule, the derivative of its argument. Well, the derivative of its argument is 1 plus, and then we have to take that derivative of the square root, which is 1 over 2 root x squared minus 1 times, again, a chain derivative of 2x. Or not derivative of 2x, but derivative of x squared minus 1, which is 2x. So again, by this point, you should be okay with the chain rule. So that's what we get to. And you can see at least the 2's will cancel beautifully here. I'm going to multiply both numerator and denominator of this right-hand side by the square root of x squared minus 1. If you do that, you get the square root of x squared minus 1 plus x over x plus the square root of x squared minus 1 times the square root of x squared minus 1. Again, all I did was multiply numerator and denominator of this expression by the square root of x squared minus 1. I didn't bother distributing in the denominator because if you look, these pictures, these pictures right here are the same pictures, so they'll cancel beautifully. That numerator is x plus the square root of x squared minus 1. That denominator has a factor of x plus square root of x squared minus 1. And so they'll cancel and become 1 over the square root of x squared minus 1, which is exactly what we wanted it to be. So again, working with the derivatives you might be asked to prove it, but man, if it was my students and I were to ask them to prove this on an exam, I might just give them the formulas for the inverse hyperbolic functions, what they are in terms of natural logs. It's just much cleaner to prove it that way, which makes it kind of moot to ask them to prove these ones on an exam. All right, let's see what else we can do. Really, this is going to be just like if you were working with any brand new derivative. You're just going to use it in rules that you've been using all along. So if we were asked to differentiate this, I'd say y prime is equal to, it's a product rule. So the derivative of the first would be 1 times the second, so times the tangent inverse of x, plus the first times the derivative of the second. Well, the derivative of the tangent inverse, if we go back a page, derivative of the tangent inverse is 1 over 1 minus x squared. So I'll write this over 1 minus x squared. And then plus the derivative of a natural log is 1 over its argument. And then we have to multiply it by the derivative of its argument. So the derivative of a square root is 1 over twice that square root. And then by the chain rule, take the derivative of this 1 minus x squared, which would be a negative 2x. Simplifying this out, you can see that it actually does simplify a little bit. This will be a tangent inverse of x plus x over 1 minus x squared. And then the 2's on this last expression will cancel, and it'll be x over 1 minus x squared with a negative in front. So minus x over 1 minus x squared, which is beautiful because this just comes down to the tangent inverse of x. Very, very beautiful. Now there is a little bit of a limitation here. The tangent inverse, actually it's, never mind. It's not an issue. I was going to say tangent inverse, you must mention that there's a domain issue at 1 and negative 1, but the hyperbolic tangent inverse won't allow you to have a negative 1 or 1. You don't need to know that. But anyway, mechanically, that's how it's done. There's not much else that you could do. You now know at this point, or at least you should know at this point, derivatives of polynomials, exponentials, logarithms, trig functions, inverse trig functions, hyperbolic functions, inverse hyperbolic functions. Let's see, what else? Offhand, it's the group that I can think of. And then those are the functions that you should be able to take derivatives of. And then the methods, or techniques, if you will, would be the product rule, the quotient rule, chain rule. Let's see, implicit differentiation, logarithmic differentiation. Those are kind of the methods to taking derivatives. I'm sure I could possibly have missed one, but I actually don't think I did. All right, that finishes it up. I hope you have a great day.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.